not say your answer is wrong if you have 3 significant digits and your answer is close to 27. Does everybody understand what I'm telling you? Okay. So number 2, I have 29.5 grams. If you have an answer close to 29.5 that has 3 significant digits, your answer is correct also. Number 3B, 0.5. You need 3 significant digits. So if you have an answer around 0.5 that has 3 significant digits, you're fine. Mine says 0.500. Okay? Same thing in number 4. I have 0.5 again. I need 4 significant digits. So mine is 0.5000. You could have 0.4999 as long as you have 4 significant digits. Number 5, 4.068 times 10 to the 24th atoms. Again, 4 significant digits, somewhere in that ballpark. 4.068 times 10 to the 24th atoms. 6B, somewhere around 6.05 grams. You need 3 significant digits and around 6 grams. 7B, 3 significant digits. I have 1.50 times 10 to the 23rd atoms. Number 8, 8B, you need to have compared the number of grams of neon and fluorine to determine who has the larger atoms. So you had to draw 2 charts. You get 6.02 times 10 to the 23rd atoms of fluorine and 5.66 times 10 to the 23rd atoms of neon. So who would have the larger number? The first one, the fluorine. You have no way of knowing who has a larger number without drawing 2 charts. Okay? Otherwise, it was just an eeny, meeny, miny, mo guess. All right. Which ones do we need help with? Sophie. Number 3. And I heard someone yell 4. All right. Number 3 says we have 11.5 grams. Now, number 3 and number 4 both say in the question to find the moles of atoms. Now, 3 and 4's question may be simply in the wording of the question, and once I fix that, I may have solved most of your problem. All right, are they asking for number 3 and number 4 for moles, or are they asking for atoms? Which one do they want when they say how many moles of atoms? They're asking for moles, okay? They're not asking for atoms, they're asking for moles, okay? So we're going to take this 11.5 grams and we're going to change it into moles. So we're putting grams on the bottom and we're going to moles on top. So using our 2 conversion factors that we learned right here, which one do I want, top or bottom? I want the bottom because I have moles and I have grams. So what's going beside moles? 1. What's going beside grams? All right, so we're going here. Moles is getting a 1. Grams is getting whatever we have beside the atomic mass. So looking at our question, number 3B had sodium. So sodium, when I look up there, has 22.9 for an atomic mass. Okay? And I only know them to 1 decimal place. So 11.5 divide 22.9 gives me 0.5. Okay? Now, I didn't use the same numbers the textbook has, so the answer I called out was 0.500. On my calculator, I got 0.502 moles. That is just fine for what I called out right there. That answer has 3 significant digits. My answer has 3 significant digits. If that's the answer on my key, this is the answer you write down. They're both fine. They have 3 significant digits. Okay? Number 4 says we have 3.011 times 10 to the 23rd atoms. 3.011 times 10 to the 23rd atoms. And they want us, again, to find how many moles. Okay, let me flip to the page that has the wording. All right, it says how many moles of atoms. Okay, so again, they're asking for moles, right? So when I look at this question, what's going on the bottom line? Atoms. What's going on the top line? Moles. So this time when I cruise back, which one of these two do I want? The top one or the bottom one? The top one. So what's beside moles? 1. What's beside atoms? I heard somebody started. Avogadro's number. So 6.022 times 10 to the 23rd. So 3.011 second EE23 divide 6.022 second EE23. So 0.5. This time I got a flat 0.5. But I need how many significant digits? I need 4. So how am I going to get 4 significant digits? I'm going to add zeros. And then I'm going to write moles. All right, there was question 3 and 4. What else do I need to do? Anything else in the homework bothering us? No? So if we had the quiz that I've already got run off right now, we'd be fine. Some of those quizzes from yesterday sucked. A couple years ago, we had a rough couple weeks. I told my kids, I said, look, I'm going to suck at this job. I said, I might have 3 plaques over there to say I'm the teacher of the year. My scores might be stellar. I said, but I'm going to move to Montana and become an alpaca farmer because I am not doing so hot at this job. And they all thought I was kidding. You people are going to need to start putting money on my desk to start buying my alpacas or start looking up some land prices in Montana for me based on those quizzes yesterday because we're not doing too hot. We sucked yesterday on that quiz. I didn't teach it very well or y'all didn't learn it very well. Andy, you did fabulous. Okay, so stop looking at me like I'm nuts. You did fabulous. Okay, a couple of the rest of you in here did fabulous. Okay, the rest of us, we got a little bit of improvement to do if we want to keep our grades up because there were a whole lot of 60s and 70s. Y'all did okay on those protons, neutrons, and electrons. Question 1 through 4, wiped y'all out. Okay? Wiped y'all out. Y'all could tell me what an atomic number was. Y'all didn't know jack about questions 1, 2, or 4. Now, was anything on question 1, 2, or 4 not covered the day before? Did we not talk about the mass and charge on an electron? Yeah. Did we not talk about the parts that made up an atom? Yeah. Then why didn't we know those? We forgot. We forgot, or we just didn't study that part because we did the other parts for homework. Yeah. Okay. Now, I know we practice the parts that are harder to process. It doesn't mean the other parts aren't important when we do those, okay? So we're going to take a few minutes, practice some mole conversions, because my self-esteem can't handle many more of those quizzes like I got yesterday. I was feeling a little suicidal when I went home last night, all right? So find your homework sheet. We're going to do 4 more practice questions, and then I'm going to move on, and tomorrow when I grade papers, I don't want to see any of that crap like I had yesterday. All right? So, let's say, I got to find paper. I don't have one. Let's say we do question number, let me see here. Let's do question number 4C. Let's do 3C. Let's do 6C, 7C, and application problem number 1. Okay? Those 5. And I will help anybody who needs my assistance. Now, I'm going to turn my book this way so you can check your answers as you go. Okay? I'm going to hand back yesterday's quizzes. Because some of y'all did fine. Some of y'all did not do fine. Now, you did test corrections yesterday, and I'm still working on those. And fix those pieces you didn't know at the top by the time we take the test. You will see them again. Ooh. The other day when I handed out papers. All right, who's got a question? Doesn't know how to draw some charts or stuck and told me you didn't have to do your homework and we're going to need help.
Right here.
Come, we'll show you. All right, what's wrong? All right.
I am fine. I'm having a stupendous.
Draw a chart. But you give a date in. What does it say in number 3C? What's in 3C? What's the given data? Right here. All right, Xavier, what are we starting in? What'd you put in the top of that chart? So from a gram, we have to go to a what? Put a gram on the bottom of your factor label method chart, right? So what's got to go on top? Now, did they ask us for a mole in the chart? Is that what they asked for in the question? What's it say in number 3? How many what? Remember what I told you just a second ago? Asking for moles. Remember, in question 3 and 4, what are they asking you for? Moles or atoms?
Moles.
They're asking you for moles. Okay? So how many moles? So if they're asking us for moles, do we need to draw a third section? No. So you're done. All you got to do is fill in that spot right there. So what do we put in the spot with the grams? Exactly. Where do you get a mass from? Exactly. So, what mass are we going to put there? Exactly. All right, try the next one. What's wrong? Pencil issues? See what I have over there. If I haven't been picked clean, I still have a pencil. If not, see what you're doing. Fair, use a pen. I had pencils over there at the start of the semester, but I may have been picked clean at this point.
That's the front in your pipe.
I don't. I only use wood pencils. Anybody else have a question? Question. Mm-hmm.
You just do.
Oh.
Yes. You have a question? Yeah. Okay, so that's a what? To put atoms beside me. So it's on the bottom of the chart. Mhm. So from an atom, what do you gotta go to? So put moles on top. Now, if they ask for moles, we're done. And if they didn't ask for moles, then we draw another section. If they ask for moles, we're finished. What they ask for. Then we're done. All you gotta do is figure out what number goes there. Mm-hmm. Yep. You can do those 5. You can do the quiz.
Who needs 5? You do.
You're doing them. I'm only offering tips. And tonight, you need to go home and rework them and make sure you can do that.
You want from atoms onto ground, and you come up with this, do I have to put it on
Negative.
times?
Yes, ma'am. If you don't, tomorrow will be -2 on your quiz. You know, question, you just hold the paper.
I asked him if we're going from atoms to grams, and it comes up like this.
Yeah, there's an E at the end. You gotta write that as times 10. See how she's got an E at the very end of her calculator? Don't forget your exponent. It's a common mistake. People see that first number, they don't look all the way to the end to catch that exponent. Okay?
Oh, you do that.
Well,
They put this in the calculator.
yeah, so you can say this number, and you can say times 1 if you want, or you can just say this number divided by that number. Yep, we gotta do that, remember? No times, just second E. And then what's the E? Uh-huh. And then you gotta say divided by what? On the bottom. This number's on top. This is like a math class. This number's on top, and this number's on the bottom.
Right
This
here.
number divided by this number.
That's number 4.
Which one?
Yeah, I see
This.
that one or that one.
Number is canceling with that.
I mean, it's,
Units cancel. Now you gotta deal with numbers. Now you can multiply this times
Oh,
the 1 if
see,
you want.
right.
But you know math
Three
class
C, this
multiplying by 1 is doing that, right? So you're just really dividing these two numbers.
157. Oh my. Oh wait, hold on. I'll look at the wrong thing. 100.
Okay, so now round that, so you have how many significant digits? So you have 3 significant digits in my answer.
where? Oh,
Got that right, and I got that.
And then what unit?
That's it.
So if we go back and do this one, what are you gonna do to calculate? Okay, so divide, and how many significant digits do you need in your answer? Okay,
We should have turned this in as well.
hmm?
We should have turned this in. Well, I did good on this one.
Well, that should mean you do really well tomorrow on the quiz. I told you, historically, this is a really high scoring quiz. I should not be suicidal tomorrow when I grade you. You shouldn't be, you should be like, dang, I know this stuff, look at my good grade. Okay? Good. What's it say you can go through from an atom? Okay, so that's gotta go on top. Good. Good. Almost there. And I've done virtually nothing to sit here.
That's what I'm saying.
Yes. Except for mine. Oh, no, I have it. You got it.
That's not gonna help me.
Why?
I'm gonna forget it, man.
You sound like my daughter when she says, I can't remember this.
That's
Yes, you can. Yes, you can. It's called practice. I can't help that you don't like to study.
Try. Studying.
Yes, it does. Is that what the element is? I don't remember.
Let's see here.
Then, yep, that's what you're right. You punch it in. You can either divide and then multiply, or you can multiply first and then divide. You do whichever one comes more naturally to you.
I did not get negative this morning.
And I didn't get negative right here on 4C either.
All of them up?
Oh,
All right, so see how I have up there in the top? See, I have it drawn where if you start now, you gotta go to what next?
see, you got what I got there, but this says it's a negative 9. It's since a
This,
negative
I
9.
have, are you changing?
Yeah, that's what I'm saying. I don't get that.
Well,
I didn't get the negative.
You also.
I'm not asking.
What did
Oh,
you?
Jesus.
Yeah.
If she can
But which one is that?
show us that one, because I don't know.
Okay, so since you're starting in atoms, you
Which
got
one
the
is
little bump.
it?
Cancel out. And then on the top, you're gonna go to what next? Yep. If they want more, they have to math, right? So extend your chart.
Oh, it's like so 4.
Yeah.
Where you can write some-
See, that's something.
What'd you get for number 2, Marissa?
I was here first.
I was here first.
I was here.
3C.
Point 1. 37.
I didn't get that. What'd
I
you
got
get?
37.4. I rounded the
I got 1.35.
5C. Do we have 5C?
No,
No,
it's
6C.
6C.
I did the right.
Okay, I got that one.
265. I got 264.
7.
What'd you get, Bobby?
Okay, I got that one. I just didn't get 4. Did I put the wrong?
231.
226.
I
No, I know.
Where are the answers to the see?
Is that right?
Yeah, 39, 9, 47. Hey, I'm lit. Let's get it. Hey. It's marked out. Yeah. Oh, look at that, Jamie. Oh, whoa, 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 whoa.
What you say, choose like that.
I feel smart now. David,
Who else has a question?
No.
All right.
Did you get
The way he do it.
That one is Xavier. 4C.
That should be correct on the first one. The chart is right, the answer is wrong.
Oh, God. Yes.
Chart's wrong. All the charts are wrong.
Where's the one? For the application. Yeah.
Yeah.
I don't know how y'all get it up and ask her.
All the charts are correct.
Karen, what did you get for the application? The last one? 39.83. I think I 39.
What does it say in there?
It says 39.9%.
Most of you read it.
I don't know how to
All right. What else? Yep. Let me see how you punched it.
This one, take it some water.
The E.
You put E to the 22 and not E to the 23.
Everyone's getting a 10, but I'm doing 30.
I think biology.
See how you said times 10 to E 23? I say times 10. Okay? You say when you put it in, which one we punch it in? This one, 4.50. Second, EE, and then you just tell it, yeah, you just say 12, E12. Then times 10, 12, you just say 12. Okay? And then keep going.
Yeah.
I didn't like it.
Who else still has a question?
Zero, very good.
Who else still has a question for me? Anybody still have a question? Anybody still working? 'Cause I got a couple folks checking their social media because they're done. Yeah. They can hear you long. It's like an hour and 45 minutes.
Wow.
Cause like even
Right.
last semester, Miss Love's class was long. It was an easy class, but I just felt like I was in there forever.
You are in there forever. Thank grab and go. They made it 10 minutes longer to accommodate grab and go. First period is the shortest, only 90 minutes. Second period is the longest because they put an extra 10 minutes, so it was 95, and then they added 10. And then third and fourth are 95 each.
Give it to me. No, you didn't.
Looks like you might be part.
Well, why would you? I would use.
All right.
All right. So, in case you have not checked your answers, the answer for number 3C should have been 0.1. All right. So if you did not check and get an answer somewhere around 0.1, your answer should be in that ballpark with 3 significant digits. 4C is the one I had scratched out in the book here that some people did not realize I had scratched out. So I found a darker pen to mark that out. All right, because that one's calculated wrong in the text. All right, that one should be 37.3 moles. Number 6C should be 2.65 times 10 to the negative 10th grams. Now, I think it was Jaden who pointed this out. If she just wrote 2.65 grams, would that be okay? And the answer is no. So tomorrow on the quiz, make sure if you're calculating something, you notice if there's an E at the end. They're 20 points each because there's only 5 questions. So if you forget the E, that's a -2 mistake. okay? As long as your work's all right and the charts are right, then I'll give you 18 of your 20 points. So don't lose 2 points because you forgot to check for the E at the end of a line if it's got an exponent. Number 7 should be 2.31 times 10 to the 22nd atoms. So somewhere in that ballpark. And then the last one, the application problem, you're finding average mass somewhere around 39.95. And that could be a unit of either AMU or U. Questions about any of the 5? Now, if you can do those problems, some variation of them, okay, they will not necessarily be all those exact same conversions, but there'll be some type of 4 charts and an average mass, and you should be able to do the quiz. Questions? Most fabulous. All right, we're going to switch to naming for the rest of the class period. You can put your calculators away. That blue chart I just gave you, though, don't put away. But you can put your calculators up. We're done with calculators for the rest of the class period.
I'm sorry. I struggled with questions this morning. There you go. You can't end up anyway, right?
Shut up.
What? I said, yeah.
I think people like it cool about
All right. We're going to talk about nomenclature the rest of the day. Okay? We will test again sometime next week. Best guess, what's today? Thursday. Best guess is about Thursday of next week. All right, so nomenclature. Anybody know what nomenclature is? It's not unique to chemistry, which is why I asked. Okay, that's exactly right. All right, it's a Latin word, and it just means system of naming. And the reason I asked that question is because the word nomenclature is Latin for naming or system of naming. It is not something you only find in chemistry. Lots of disciplines have systems of naming. Not only chemistry has that. So you might have used distinct systems of naming in other subjects here at the high school. Now, we're going to talk about naming because it's a huge part of our course. Now, ideally, we would like to talk about 2 types of compounds, and we would like to get to acids. Unfortunately, acids is probably not going to happen. So, what are the 2 types of compounds that we will work with predominantly this semester? Any idea what the 2 types of compounds are that we're going to work with? Usually people have seen these before they get to me. Any clues? They start with an I and a C. Okay, so much for that. All right. One is called ionic. Any clue what the other one is now? Okay. Ionic and covalent. Now, we'll talk about their electrons and who loses and gains and who shares electrons down the road, okay? If I was a traditional chemistry teacher, I would go there and talk about the atom and all of that and where the electrons are and valence electrons and the periodic table and bonding next. But I deviate from everybody who's probably ever taught chemistry in this county and state, and I don't teach it in that order, okay? I don't recommend you transfer schools right now either, or in the next 4 weeks, or you're going to be screwed. So, how am I going to talk about it for right now? An ionic compound is a compound between a metal and a non-metal. And a covalent compound is between all nonmetals. Now, we will get to how to recognize them using all that other stuff I just referred to, because you will know more about that than you ever wanted to know. So, thinking about what I just wrote up there on the board, because that's important for what we're going to do here in the next couple weeks. How are you going to know where a metal and non-metal is? Because you should all already know that. Jaden? Exactly. Does everybody have what they need off this board? Okay, I don't hear your nose out there. All right, so if you don't know what Jaden just said, you might want to draw this rough sketch of the periodic table. Does not have to be a thing of beauty. Now, she just said that zigzaggy line. That zigzaggy line has a very technical name. What do they look like? That's what they're called. Okay? We generally refer to this as a staircase. And on the staircase, we find a certain type of elements. Does anybody know what kind? They have a special name. I didn't write their name on the last slide. Starts with an M. What? I thought I heard it. Not metals. Nope. They're called metalloids, okay? A lot of times, some teachers will teach them as semi-metals, all right? You see the things over here on my colorful periodic table in green? The green is the staircase over there, okay? I just threw that out there. We'll talk about it down the road. Now, here, I'll even use this light blue. Everything over here are my metals. Okay? Everything over here are my non-metals. So my non-metals are where in relation to my staircase? Okay, think left or right. They're on the right. Okay? They're on the right of the stairs. And that's the way it's described on any test or any description you're going to read. So, where are the metals at? They're on the left of the stairs. Now, there's an exception that you probably learned in another science class somewhere in your distinguished science background. Who is that exception? In your science background, you learned there's an exception to that rule about metals are on the left, non-metals are on the right. You can look at your periodic table if you want to see if you can figure it out. Some of you probably know.
Is it one?
There's just one.
Is it hydrogen?
It is. Okay? Hydrogen is a what? Is a gas. And it's over here with the metals. And it's actually a what? It's a non-metal. Okay? So, when you see it, you have to remember, even though it's over here on the left with all the metals, it's a non-metal. Okay? So, we're going to learn to write the names of formulas over the course of the next week. It's going to be important for us to be able to tell whether something is an ionic compound or whether something is a covalent compound. Now, going back for a second. To be an ionic compound, ionic compounds are what? Metals and... So, if I come from the blue side, meaning the left, and the right, I'm a what? I'm ionic. If I come from over here on the right only, two nonmetals, I'm a what? I'm covalent. So, if I give you Tell me what kind of compounds I have. I want you to write it down. Okay. Some of you think faster than others, Mario, so I got to give everybody a shot.
So.
All right, we got them? Okay. I'm going to send this to the director real quick while y'all finish. All right. How about now? We still looking for elements? Got them done? Where we at? Looks like I still got a couple people looking. All right. So if we look at CO2, what can you tell me about the placement of CO2? Where are they?
It's on the right.
It's on the right. So these are what kind of compounds? It's covalent. Okay. They're both nonmetals. This is a nonmetal. This is a nonmetal. So it's covalent. What can you tell me about NaCl? It's ionic. This is a metal. This is a nonmetal. So it's ionic. All right, Xavier, tell me what you got for PCl3. All right, everybody agree with Xavier?
Yes.
All right, tell me what you got for KBr, Stephanie. Okay. And what do you have for HCl, Karen? Okay, I get a lot of that. It's covalent. All right, why is this one covalent? Why does it throw so many people off? All right. This one is covalent because H is a nonmetal and Cl is a nonmetal. They're both nonmetals, so HCl is covalent. Okay, so why are we wasting our time going through and learning how to do this? All right, we have to learn two systems of naming. Okay. Now, I'm going to give you an abbreviation. It's called the IUPAC. It's called the International Union of Pure and Applied Chemistry. Now, at the end of the year, you guys are going to swear to me I never told you that. Because the test questions, when we review for the exam, are going to say, name this using the IUPAC convention. You're going to be like, what the heck is that? All right? Everything that we're using to name is the IUPAC convention. Okay? I'm not teaching you anything that's not that convention. So, what are these two systems that I speak of? One is called the stock system. The stock system, just to help you have something to hang it on your brain and be like, oh yeah, I know what that one is the one that's going to have Roman numerals. Okay? Now, the stock system can be used with both. Okay? Covalent and ionic compounds. We can use the stock system with everything. Everything. Some of y'all are going to hate the stock system. Now, it's the one we're going to spend most of our time with. So, why am I making a big deal about this, some of you say? Because old system, which we still use, the one with the prefixes, can only be used with covalent compounds. You will hear me say this 20 times before the test. I will say it repeatedly, ad nauseum. And still, people after I teach those prefixes will be like, oh, I like that way better, Ms. Wall. That way is easier. I agree with you. It is easier. However, it can only be used with what types of compounds? How do you recognize a covalent compound? They're where? They're on the right. They have to be what kind of elements? They have to be nonmetals. They have to be everything over here. Look at that periodic table over there. 3/4 of that periodic table is made of what? Are most of the compounds we're going to see in this course going to be covalent? So, can we rely on only being able to use this old system? Okay? That's the problem. People like this way. That's great. I do too. But we can't just use that way. We have to be able to name this way. Okay? This is the predominant way we use in chemistry, even though it's a pain in the rumpus. Okay? Everybody with me on that? So, what are the things we need to do in order to use the stock system? Because we're going to start today. When you leave today, you're going to be able to write a formula and write a name. That's the goal, to be able to do both of those things. So, I gave you a blue card, right? So, what are we going to use? Well, all atoms have oxidation numbers. Okay? Basically, they lose or gain electrons. You don't have to figure out these numbers. If we had already learned this material, which is why people teach it backwards from the way I teach it, because you would have already learned this stuff, you would already know the numbers. Some teachers make students memorize all this stuff.
Yeah,
I don't. I'm giving it to you. By day 60, you will have learned it all anyways. So if you look at the top of that card, under where it says oxidation sheet, what does it say in small print? So at week 12, which is day 60, this card can no longer come out of your notebook and be used in class or any quiz or any test. Because by day 60, we will have learned all the information we need so that you don't need this card anymore. But until day 60, I'm giving it to you to use on what you need. Okay? With the exception of 4 acids. 4 acids you have to learn. So flip it over to the back side. We need to mark this, because they will not appear on the oxidation sheet that I This wall will provide to you on every quiz and test. Now you can't use yours, you use mine. So I will come over here and I will hand out these lovely oxidation sheets that look just like yours. Minus the acids, see my little acid chart, it's a wee bit shorter than yours. Because the 4 acids I'm asking you to learn are on this chart, on your chart. Because if I give you the chart with the acids on it, so you learn the acids. Of course not. I wouldn't learn them either. So, which acids is it that I want you to learn about? They are the bottom 4. So, in that chart, if you star, highlight, circle, whatever it is you need to do, put your name on this. So if you lose it, I can give it back to you. All right? You need to know these by Tuesday. Tuesday.
Those specific ones.
Well, we're having a quiz on naming on Tuesday, and you might see one of those on Tuesday. Okay. I know Xavier's thinking I should have taken physical science.
I should have.
Yes. You might have better have. Would have been much easier. I don't teach basket weaving. Now, hydrochloric acid is stomach acid. It's HCl. You need to be able to tell me that. All right, sulfuric acid is battery acid in a car battery, H2SO4. Nitric acid, well, we can use those to make fertilizer bombs, but we don't need to talk about that. And phosphoric acid, that's my personal favorite because I love this phosphoric acid. Anybody want to guess what that was in? Yes. H2PO4 is a personal favorite of mine. Okay, I can't stay this fluffy size without my phosphoric acid. Now, so, what are these oxidation numbers going to do for us? All right, we have cations. What did we say cation was? See, this is why I whacked off all those points on the top of those quiz papers yesterday. This is a vocabulary word we just learned the other day. Why are we all going? I don't know. Yes, it's a positive ion. This is why I'm telling y'all my alpaca fund should be growing up here on my desk. All right, anions. What are anions? They're negative ions, okay? Now, so when we write names, we're going to use positive ions and negative ions. So we're going to look up, okay, things like Na with a +1, or O with a -2, or an Al with a +3, or a, let's just use an F with a -1. Okay, we're going to look those things up. Now, as we branch out into tomorrow, we'll have polyatomic ions, but we'll save that till tomorrow. Now, we're going to use these numbers to write the formulas. We're not going to come up with them on our own yet. We'll talk about how to do that in about, where are we on? Day 11. Somewhere around day 50. Day 50, 55, somewhere in that range. Okay?
Do what?
Around day 50.
Do what?
We'll learn how to find these numbers on your own. Okay? Everybody caught up? Got what they need? All right, so let's start easy. Let's talk binary and ionic. That's all we're going to do today. So what we're going to do the rest of the class. Tell me what binary means. Okay? And ionic. All right. Xavier said binary meant 2. Okay. So Xavier said binary means 2 elements. And Jaden said the 2 elements have to be a metal and a non-metal only. Now, those of you who had a good 8th grade experience probably did this. Okay? I know Fabian did. Those of you who had a good 8th grade experience probably did this. Okay? We're going to write down the steps to write formulas. Tomorrow we will not have to write the steps because they're the same steps. Okay? All All right, so what do we have to do to write formulas? It's the easiest of the two things to do. We're going to write names last. Number one, look up the symbols. Everybody always says to me, Ms. Wall, why do you write down, look up the symbols? Because I just gave you an oxidation sheet. I gave you a periodic table, both of which have the symbols. There are two hanging in the room. As soon as you write down the wrong symbol, your answer is what? Wrong. There is no partial credit in naming. Fluorine is an F. If you write FL, it is wrong. Potassium symbol is K. If you accidentally write P, it is wrong. Sodium is Na. What do you think I get? I get S and SO a lot. Okay? It's wrong. There's no discussion. I just write X and move on. Okay? So look up the symbols if you're not certain. It's a shame to have a 10-point question, accidentally write the wrong symbol, and it's -10 and I go. Okay? I don't even give it another thought. Number two, look up the oxidation numbers. Lots of people ask me, do we have to memorize the periodic table? No, I've just given you one. Look it up if you don't know it. Number three, criss cross the number. Oops, hold on. I need to add something to number two. I hate it for writing in ink. The positive oxidation number is always first. The negative oxidation number is always last. Number three. Now I can do that one. Crisscross the number only. And number four, reduce if necessary. I'm getting ready to tell you. Really, I usually explain why not. I'm not going to leave you hanging. All right, we caught up? All right, so let's say that we want to write the formula for magnesium fluoride. All right, a lot of you know the symbols for these. I tried to pick something that was very easy. All right, what's the symbol for magnesium? Mg. Now, anytime you have a two-symbol element, the first letter is always capital, the second letter is lowercase. All right? And I'm going to write that over there in just a second. If you have fluoride, fluoride symbol is fluorine. We're going to talk about where that IDE comes from in a minute. So this one's going to have, here, I'll just write it over here. All right? Fluorine has one letter, so its letter will always be what? Capital. We're not going to have a lowercase f there. I'm very particular about that. If you write MG, what happens? It's wrong. Okay, we don't write them that way. Now, step two, look up the oxidation numbers. Oxidation sheet is in front of you. Find the oxidation number of magnesium. +2. All right. What's the oxidation number of fluorine?
Which one?
What do you mean, which one?
It's like,
All right. Just gonna look at what I wrote here. The first oxidation number is always what? So magnesium has to be positive. The last oxidation number is always negative. So fluorine has to be what? So when you look up fluorine and you saw that it said -1, +1, +3, +5, and +7, that told you it had to be what? -1, because fluorine is where in the name? It's last. Does everybody see what that rule means? Okay. Now, step 3 says to crisscross the what? The number, not the sign. Now that we know that this was positive and this was negative, we don't need that. All we need are the 1 and the 2. So the 2 and the 1 are what we're crisscrossing. The 2 is on magnesium, right? It's going down to fluorine. The 1 is on fluorine. It's going down to magnesium. Now, before I rewrite this in math class for step 4, can a 1 and a 2 be reduced to any other lowest terms? 1 and 2 are in lowest terms, right? So we don't have to reduce anything. The answer is MG. Do I write a 1 in math class like x to the first? We don't write it in science class. F2. Now, I will tell you, if you need to write the 1 for a couple days until you get used to it, I won't take off, okay? I will never write the 1. But if you need to do this for a day or so just to get the feel for how things look, this and this are the same thing. If you do that, I won't take off, okay? But I won't write it. Everybody with me? Feel okay about it?
When you crisscross, don't use the sign.
You don't use the signs. That's only to make sure you got the right one in the first and the last place. It's its only function. Okay? So, if we have something like sodium phosphide. All right, sodium has what symbol? It's what? Na. And a lot of times I do the oxidation number while I'm there so that I don't have to look it up twice if I'm looking up the symbol. So NA's oxidation number is what? All right, and phosphide is what element? It's phosphorus, so P. And what's its oxidation number? -3. Anybody not know how to get the symbol or the oxidation number? Because without that, you're sort of dead in the water. Anybody? Okay, so taking the 1, it comes over here, and the 3, and it goes over there. So you have Na3. P. You can write the 1 if it makes you happy, but I'm not going to write it. Now, let me just say this. What if you did that? It's wrong. Will I give you any partial credit for that? No. There are no positive or negative signs written on a subscript. Does everybody understand that? Okay. Think you could try a couple? Oh, hold on. No, we can't. Forgot. What happens if you have something like, let's do this one. So we have that. All right, so look up manganese. Tell me what makes manganese different from the last 2 that I gave you. Tell me what makes manganese different. Justice? Huh?
Yeah, it's a metal.
All right, it is a metal, but it's a positive element, right? And when you look up its oxidation numbers, they're all what kind? They're all positive. So when you look at manganese, how many positive numbers does it have? Okay, what are they?
2, 3, 4, 5, 6, 7.
Right, got all those. So if it's a positive number, did I give you a rule for which positive number to use? There isn't one. So how are you going to know which positive number to pick? I have to tell you. Okay? So when we turn around and do naming in a minute, you have to tell me. So I'm telling you, this right here is the oxidation number of the first element. You don't even need to look it up. Okay? Don't need to look it up. It's given to you in the name. It's telling you you're picking the 7. All the rest of those are junk. That will always be the first element's oxidation number. So you know that manganese is a 7. Now, oxide is what? Oxygen. What's its oxidation number? It's a -2. So what are we going to do with that negative and positive? We're not going to do anything with it, and we're going to crisscross them. So the 7 comes down, the 2 comes down, and we get Mn2O7. Now, this worksheet is done in sections. We are only doing 1 through 8. Some of you may finish it before I stop you. Some of you may not. Okay. All right. Do 1 through 8. Do not work ahead where you were hollering, I need to erase. Randy, you got a twin or just another brother? A twin? I'm reading the rest of the changes. That's why I asked. I'll say he probably doesn't wrestle in your weight class, right? Tell him to beat you up. Somebody else gonna do that for I like your letters better than yours. It's got it's flying in the air. I'll bring it down so it's a subscript. It's the right number, it just needs to be lower. What was that? That's a 2. That should be a 2. Doesn't matter what that's like. That's a 2. Okay, so that would have been a 2. But that's going to be 2. Got one symbol wrong and a number wrong. That is +3 for my station number. And that symbol is not good. All right, we run through the answers real quick. Okay? You should have, not one. I don't have to stare over your shoulder. Yes, sir. All right. NAF, MgCl2, Al2S3, NIF2, Cr3N2, Cu2O, ZNI2, CABR2. Questions? All right, we're going to write names. All right, that's what we're going to finish today. All right, number 1. You'll write the name of the first element. Now, and just to specify again, these are for what kind of compounds? Binary and ionic. All right. Number 2, add an IDE ending to the second element. That's where those IDE endings are coming from, because we have to add an IDE ending to the second element. Now, step 3 is where we have issues. You have to check the first element. If more than one oxidation number, you must use a Roman numeral. All right. Now, in case you don't know the Roman numerals, there's 1 through 7. Now, if I'm only teaching 1 through 7, what does that mean? We're only going to do numbers 1 through 7 in a first year class. And y'all are a first year class. You are not going to be asked to go above 7. So if you try to do a name and you need like 8, 9, or 10, you should think, oh, crap, I'm doing something wrong. Because you are not going to have a Roman numeral greater than 7. Okay? All right. Everyone got it? Do I need to wait? Where are we at? Okay. So I don't want to cut anybody off who's still writing. All right. So let's say you have to write the name for AlCl3. All right. Name the first element. So we're going to write aluminum. What's the name of the second element? Chlorine. We need to change it to what? Chloride. Now, I have learned over the years, y'all can't spell. Okay? So, turn your oxidation sheet over to the back. Down at the bottom, it says, what at the very bottom? Common spellings of binary ions. Okay? Now, I certainly don't have all of them, but I have the vast majority of common spellings of binary ions because y'all can't spell. Okay? Sad as it is to say, last week, I had my son pack mine and my daughter's sandwich, and he wrote our names on the bags, and guess what? He spelled my daughter's name right. Spelled my name wrong. Okay? He's 12. So, I just assume people can't spell names right anymore or spell anything right. So I put those on the card to help everybody out. So if you can't spell, by all means, look, because people always ask when I grade quizzes, well, are you taking off for spelling? People, I just gave you a card for them spelled right. Okay? If you forget a vowel, probably not. If it's completely jacked up, yes. Okay? Now, step 3. Check the first element. How many numbers are listed beside it? Okay, so you're looking up aluminum. Okay, so out here beside aluminum, how many numbers are listed beside aluminum? That's right, that is 1 number. The 1 number happens to be what? A 3. There is no Roman numeral. Okay. Because there's 1 number there, we are not putting, okay, no Roman numeral needed. All right, because every time aluminum is used, what is the only oxidation number aluminum will ever have? 3. It's the only one it can ever be. So every time we write a formula, it will be plus 3. So we don't need to put a 3 here because it's always ever going to be a 3. Now, the flip side of that is something like this. Now, if we have this, everybody in here can go, oh, that's copper, and that's chloride. That's copper, that's chloride. Oops. How can they have the same name? But they clearly have different formulas. That's it. Okay? So now, look up copper on your oxidation sheet. What does it say beside copper on the oxidation sheet? It has 1 and 2. This one needs a Roman number. Now, once you know that, put your blue sheets down. You don't look at your blue sheet to get the Roman number. Don't look at it. You look at the formula. The Roman number comes from the formula. Okay? What number came from right here? It came from up there. That's the Roman number. What number came from right here? It came from up there. That's the Roman number. Okay? It doesn't come from the blue sheet. The blue sheet only tells us, yes, we need a number. No, we don't need a number. It doesn't tell us what the number is. What tells us the number? The formula tells us the number. What do you think I want you to do for homework? 4. What? 9 through 19. I want you to try 9 through 19. See what you can do. Now, what do we know that we have to do tomorrow